Look at that.
Good afternoon, everyone. I'm Mark Fergnano, the publisher of Plumbing and HVAC. Thank you for joining us here for why heat pump systems in Canada will always have a backup heating system with Tom Heckbert. Tom has over 14 years experience in the mechanical and hydronic industries, working in various technical and sales roles within manufacturers' agents, spec writing firms, and manufacturers of boilers and water heaters. He has been with Rheem now for 3 years and is currently the senior sales manager responsible for all of Rheem's wet products under the Rheem, Rude, IBC, and Raypak brands in Canada. And with that, I will turn it over to Tom.
Thanks, Mark. So I'm going to talk today about why you're always going to want a heat pump backup for your heat pump system for the heating portion.
Tom, I don't know if you can hear me, but in mine you're frozen, so I don't know if anybody else is experiencing the same thing.
You can't really get away without it, unless I'm going to argue, in fact, that the backup system to be capable of handling the entire heating. Okay. Anyway, basically, we'll talk about we're doing the introduction here now. I will go through a little bit of heat pump basics. I know it's a heat pump day, but it's the thing we'll talk about is relevant. Get to the plug down, I promise.
Hey, Tom. I don't know if you can hear me, Tom, but
you're just always going to want a heat pump. The presentation itself is not deeply technical.
Can you hear me?
But we can talk about technical stuff after. I anticipate we'll get through this.
You were cutting in and out all of a sudden for some reason now. Yep. I don't know why. We lose your video for a second and then you're back, which wasn't happening in our testing, so I don't know why. But it seems it seems a little better now.
Yeah.
Okay, let's continue and let's hope it stays stable.
So
can we start from the beginning, because I think we missed the first part.
Sure. So we're just going to talk about why you always are going to want to back up to the heating portion of a heat pump system in Canada. And my argument, in fact, is that you want 100% backup on your heating system, not just a supplemental one to make up the shortfall of the heating of the heat pump. So that's what we're going to be talking about today. And as I said, the presentation isn't deeply technical. We can talk about the more technical aspects if anyone wants to, but we will get into some of the heat pump basics that are relevant to the topic, and we'll try to get through it with plenty of time to spare for questions. So heat pumps are not something we're going to be able to avoid. We're going to have to find a way to make heat pumps work in all sectors of the mechanical industry because of their efficiency. Heat is a lot easier to move than it is to make. So heat pumps can have impossibly high efficiencies, like 500% efficiency. That's not something that you're going to be able to solve the climate impact challenges that we're seeing without implementing. But they do not have the ability to be entirely independent. They definitely have to be supported. Okay, so just a few basics. The obvious thing first is that heat pumps, it's kind of a silly name. We've had heat pumps, obviously, for a very long time. We just called them air conditioners, simply pumping heat out of a building or out of a refrigerator. It's all the same cycle all the time. With the exception of gas absorption is a different thing, but all the electric heat pumps work basically the same way, the same refrigeration cycle, where a low pressure liquid gets evaporated and the state change absorbs heat. And you can do this because you've released the pressure on it. And then when you compress it, now it's under higher temperature, and you can then but it's a vapor, and then you condense it, take the heat out of it, you condense the refrigerant back into a liquid, and the state change again now releases the energy. Well, in an air conditioner, you're doing this to push the heat out of a building, in a refrigerator out of the fridge. But in a heat pump, you're just pumping, you're going the opposite direction. You're pumping the heat from outside into the building, and so be it. The problem that you come up with is because in the refrigeration cycle, you need the evaporator, where you're taking your heat from, to be colder than the surrounding air. When you get into really cold conditions, then the water vapor that's present, it's not condensing out on anything else, because if it's the percent humidity that you're at is in balance with the surrounding air, but the coil now is colder than that air, so now the water vapor condenses out on the coil because it's not in balance anymore. So the coil starts to build up ice on it, and eventually you would have a brick of ice and a non-functioning heat pump. So the cold climate heat pumps have all tried to solve this problem by having the reversing valve, which as needed every so often, you will switch your heat pump from heat pump mode to air conditioner mode, and you'll pump heat out of the building and melt the ice off of the coil, and then switch back into the other mode. Basically anything with a reversing valve can do this. Now the modern then heat pumps, you can have, they can be in either heating or cooling mode. You can use them for heating in the winter with the defrost function, and you can use them for cooling all summer. And in a lot of cases in the Canadian climate, the heat pump that you select will be perfectly sufficient to cover the entire load on the cooling side of things. But in the winter, you get into a condition where you probably are going to see that it no longer keeps up. So with the heat pump basics and the ice topic on the radar, let's talk about the balancing point problems. So first of all, heat pumps have a declining performance. And this is air source heat pumps. We'll talk about water source in a minute. They do have some of this, but generally speaking, the water source, the water itself, the ground table is so thermally massive that it's not as much of a concern, but they still have some challenges. But the air source, as the air gets colder and colder, the amount of heat that the heat pump is able to pull out will decline. Now this is air to water heat pump, so the water that you're putting it into also affects things. But you go from a COP of 5 under ideal conditions to a COP of about 1.5 in the worst case scenario. That's a very serious change of performance. So then you get the balance point. At the same time as the air source heat pump's capacity is declining and your performance is dropping and dropping, and the amount of heat that it's getting out at a given frequency is declining, the heating requirements going in the opposite direction and growing because, of course, the air is colder and colder. So where those two things cross, the heat load mounting and the air source heat pump capacity dropping, that's the balance point. Everything to the left of the balance point here, you need supplemental heat. Now, if it is often a good idea to keep running the heat pump in this circumstance, because usually you can expect that whatever your supplemental heat is, it's not as efficient as a heat pump. Of course, sometimes you just put in more than one heat pump and you can reduce how much this matters, but usually you would want to be only supplemental rather than to just take over. Things like boilers or furnaces or electric boilers, they can all jump in to take over as needed. But more often than not, the heat pump you're going to want to use as much as you can. That's not always true. It's actually, last time I heard it, it was a rumor. It may now be a rule, but the City of Montreal is an example of a place where they're probably going to implement the code change that at -14 degrees, you have to switch to heat pump. You can't run, or to the backup. You can't run the heat pump below that because the amount of switches, of cycles for the defrost mode is too high. You risk straining the equipment. You also have an expectation of more likely unhappy homeowner who's not feeling quite the comfort level that they thought they would because the heat's turning off every hour. So they're probably going to mandate that. In that sort of sense, that's one reason you may choose to do that. Another one may be the cost of fuel at any given time. The electricity, as the performance of the heat pump drops, the amount of kilowatts you're needing to heat the home may no longer be more cost effective than just switching to gas backups. So that's another reason you may not run the heat pump when you're left to the balance point. But really anything left to this balance point, the heat pump can't do the job. So for Canada, where it's very likely that to put in enough heat pumps that you have all the heat you need all the way down to the coldest temperatures, the cost of doing that is going to be so high, it's very likely that you will put in backup no matter what, just to avoid having enormous heat pump plants with really high electrical demands. So it's always going to be the case in every Canadian market that you struggle to size the entire heat pump plant to be big enough to not need backup heating down to the coldest temperatures. Water source heat pumps, by the way, with the water table being what it is, you can usually get away with using the geofield or whatever, open water or whatever it is that you're using. Usually there's enough thermal mass there that you don't have to worry so much about it degrading in performance and the COP significantly dropping. It will go down some because you start to, like, over the course of a season, you're going to start to extract heat from the earth in enough, potentially in a significant enough way that the heat exchanger will actually start underperforming. But more often than not, it'll be enough. The problem is that water source heat pump systems, more so than a lot of air source heat pump systems, have a high degree of complexity, and therefore a higher degree of risk of mechanical failure, mechanical issue. So even in these systems, it's still, and also in these systems, it's still advisable to always have something available for a backup heat in case the geo system no longer performs the way you expected. And that's also true of air source heat pumps. There's potential for mechanical issues or other challenges that mean you still want to have a backup event around in case something happens with the air source heat pump. But it's somewhat truer of water source because of the greater complexity. It's just a good idea to have something around in case there's an issue, and you can switch over to that. So that's an argument for why you would always need backup heat in the system. But I would argue that it's not just that, and that it can't just be sized for the supplemental portion that is to the left of the balance point. And that's because the reality is most heat pumps, especially, again, this is truer for air source, but heat pumps, when they get down to cold enough temperatures, they just can't perform anymore. So most of them are rated for negative 30 degrees Celsius or negative 22 degrees Fahrenheit. At that point, the heat pump is not really supposed to be running any longer. But as most Canadians will attest, most of the years, there's at least some of the time when the weather outside is below negative 30 degrees Celsius. So if it drops below negative 30 and you no longer have any heating system because you relied entirely on heat pumps, even if you've got 20 heat pumps producing a combined total amount sufficient to heat the home, when they all turn off because the ambient air is too cold, you're in deep trouble all of a sudden. So just based on the basic reality of the climate of Canada, you're going to want to have a backup heat source for when the cold snap arrives, that the heat pump's performance is not interrupted and the whole heating system goes down. These are showing average temperatures in Celsius, but even in BC, which has historically been pretty temperate, this is no longer true. The 2010, this is the latest one I could find from Environment Canada showing this all nicely mapped out, but the average seasonal temperatures are dropping. And the potential to have a cold snap that drops well below the minimum thresholds is growing faster and faster all the time. So it's just not advisable to put in a heat pump system that doesn't have not only a backup capacity, but 100% spare backup capacity, so that if the heat pump's no longer functional, it can take over completely and cover the load right down to the cold design day temperatures that systems are designed for previously, before heat pumps were the method of choice. We were talking with Mark about it. I don't know if it's going to start a riot, because I know a lot of people like to say that it's not actually necessary to have backup on heat pump systems. But I think that that's probably a little bit misleading to say that, because realistically, what are you going to do then if you don't have a backup when you have no other heating system active or in place in your facility? Yeah, and is this the other thing to consider as we were talking about, you may want to just stop putting the heat pump on in the middle of the winter and rely on the alternate source for any number of reasons: cost effectiveness on utility rates, the cycling wear and tear that you may see on a heat pump operating at negative 25 degrees Celsius. It's not inconceivable at all that you may be going through defrost cycle up 2 times an hour, every day, all day. That is a lot of switching on and off, a lot of cycling on the equipment. So there'll be some thermal stress on the appliance as a result of having to first be so cold that it builds up the ice, and then be so warm that it melts all that ice. That will have an impact on the lifespan of the equipment in a negative way. So it's potentially advisable to simply switch and to use this like a hybrid approach to the systems, potentially for the very long term. There's arguably no way you can really get away with switching from heat pump mode to some other backup, whether it's resistance electric or gas, or someday hydrogen, because you just don't want to put the heat pump through this, and you want to make sure you get the longest possible lifespan out of it. So it's also advisable, just for the best case scenario, the longest life of the system, that you make a point of having 100% spare capacity in whatever backup plant you're using. I think it's just not realistic in the Canadian climate and Canadian conditions to think that you can get away without it. So all of that said,
can I ask one question on that, Tom?
Yeah,
I just thought of would the one caveat or one exception to that rule would be is what if we had what if it was geothermal?
Well, yeah. So the water source heat pump, you in terms of this condition where you may switch the thing off entirely because your air gets too cold, they don't suffer from that challenge. And in terms of the formation of ice, they don't have that problem because the temperatures will never get low enough. And they do a water-to-water exchange, so you're never going to deal with ice buildup on a geo heat exchanger. Well, I suppose you have it because you get ice on the ground, but it's underneath the frost line, so it's not affected by that. So you never have to worry about that. The reason that you would want to consider a backup to a geo system is, first of all, again, it is possible, depending on time of use rates and things, that it's not less expensive to run your heat pump system, even with a geo field versus gas, under certain conditions. So you may still want it for the economy of it, though. To be fair, if you can afford to put in a geo system, you can probably pay the utility. But the other concern would be you need extra pumps and extra controls and fittings and things in your doing geo. If you had, say, the pump flowing through the geo field fail, and you have no backup, your heating system is off until a new pump is there. Now, I mean, to some extent, mechanical failure of a system is always possible. If you just have a boiler with a pump on it, that pump could go down, the boiler could go down, and again, you're out of heat. But because the geo system has multiple points of potential failure, there is advantage to having something else around that can cover the load if you were to need it. But really, the water-to-water or water-to-air geothermal heat pump guys are the only ones who could probably make the claim that supplemental would be more than enough, or arguably nothing would be sufficient. It's just a bit risky. The other thing that's kind of true is even with a geofield, even if everything's working perfectly, sometimes the weather gets colder than you think. And if you didn't put in a big enough heat exchanger and you can only extract so many BTUs out of it, and you don't have any other way to top up, like if you look at the balance point curve, the heating requirement here goes up 35,000 BTUs. But if you're wrong and you need more than that, and you've only got the ability to squeeze 35,000 BTUs out of your geo system, you're going to want something else that can back it up and top up to get to the heat that you find that you actually need. And because heat pumps are expensive, they're often sized to be only as big as you think you need, sort of thing. You're not likely to put in 100,000 spare BTUs of capacity on a geo system if you think you can get away with 35. But gas systems, and to some extent electric resistance, but especially gas, it's very easy to put in a lot of capacity to back it up if you ever need it. You can put in a 200,000 BTU boiler every day of the week in most places. Put it in propane and in places where you're not on the natural gas mains, but you can put in all the spare heat capacity that you could ever need very easily, and then just plan not to run it unless an emergency situation comes around. So even for water-to-water or water-to-air geothermal or water source or whatever you want to call it systems, there's still a benefit to having something in there. Water source would be another one too. If you've got an open source system, so you're pulling from a river or some other aquifer or something, and you have to filter that water generally before you run it back to your heat exchangers, those filters require maintenance. You may find that they plug up and suddenly your system goes down, and you need to have something there to back you up while you get that addressed. It's part of the complexity of the system. There's just more things that have to be dealt with, or you could find that suddenly your heat's off and you don't have any alternative. You're going to wish in that time that you had some sort of backup to carry you through. But yeah, so is it given all of this complexity though? If you're going to put in a system that is 100% capable of covering the load as your backup, then the argument is often, well, then what's the point of putting in the heat pump system in the first place? Now I have 2 mechanical systems. I paid for twice as much equipment. Why didn't I just save the money and up it in the heat pump? The reality is they're still so much more efficient than any other means of producing heat that nothing will ever compare in terms of system performance for efficiency, for getting maximum value out of every kilowatt of energy that you consume. Whether you're measuring that as kilowatts or BTUs, it's ultimately all kilowatts, and nothing will ever be better than the heat pumps because they're not making the heat. They just move it from one location to another as efficiently as they can. So it's still worth including this into the systems for, first of all, potentially, ideally, your utility costs will be less because it's so much more efficient. And the government is doing what they can to make sure that gas gets more expensive so that electricity looks better and better. Ideally, you will save money on the costs of utilities. But it's also the case that if the government is trying to bring down the total amount of energy we're consuming per home to net zero eventually, you need an extremely efficient way to produce that heat. You need something that will use the smallest amount of energy to bring in the largest amount of heat possible, and heat pumps are your option. So it's still worth it, even though in Canada we are going to have a spare system idling, sitting around to back it up. And I would argue in every single instance. It's really then just a question of what's that system look like? Do you use multiple small electric appliances so that you can be modular and stage them to use the smallest possible amount? Or do you put in a gas product that also does, like, say, a combi boiler where it does the backup heating but is also the source of your domestic hot water? Or what is the right appliance? But you can get creative about what is the backup, and because if its function is primarily reserve heat, you might think of ways that you can better use that appliance to suit the homeowner better. But you're still going to need it. It's got to be something there. You're not going to want to rely 100% on the heat pump in terms of safety factor and making sure that your system never goes down. But yeah, so Canada, most of you probably know this, but it's worth reiterating. Canada's legislated goal is net zero by 2050. So we have, every government policy and rebate and everything has to be geared towards net zero by 2050. That means every home will have to be functioning at net zero energy efficiency if we're to hit that goal, which is not going to be easy to do. That to be truly net zero, you have to then also do on-site power generation and things like that, and that's not necessarily going to happen at the home, but you want them to be net zero ready is the idea, so that their loads, their energy requirements are so small that it's very easy to generate the power that they need in sustainable ways, rather than very high demand where you can't keep up and you have to put in gas power plants or other things like that to produce power at in a very dense way at a very high rate. So as part of this, the government will, I know the Greener Homes Grant is off now, but expect something like it to come back, because they're going to have to find ways to retrofit heat pumps into existing housing infrastructure rapidly. So to make sure that everybody has the ability to heat with the smallest possible amount of energy required. Again, whether that's being consumed as gas or electricity, it's the total energy requirement that you have to drop, and the heat pumps are the best tool for doing that. So there will be more rebates coming, and then it's worth thinking about the fact that you need the backup system, because if you're going to go retrofit in a net zero plant, or a heat pump plant rather, onto a home to try to get these efficiency targets, leave the existing system, plan to work around it, because the most energy efficient, environmentally friendly and energy efficient option is to leave the furnace there, leave the boiler there, and add a heat pump system in, layer it on top, and use the existing system as your backup. Expect that you're going to need it, so don't touch it. And if you pull it out and recycle it, then all of the energy that was consumed taking it out, all the energy that was consumed manufacturing it, was wasted. So it's better to leave it there and have that heat pump added around that system. Best results for the homeowner, best cost, best environmental outcome. But yeah, so it's as we talked about, going through these points here, the air source heat pumps are definitely going to have a more obvious and immediate need for backup, because they, by their very nature, will find that the air, as it cools, becomes less useful for extracting heat. And they are very, very likely pretty early in the season to start crossing the balance point more often than you would like, where you're turning on a supplemental thing anyway. So it's good to think about, especially depending on how big a heat pump you put in, what do you want to use for the backup system? Do you want to use multiple small appliances so that they stage easily, rather than one big gas one, say, that has to cycle a lot? When you're just barely to the left of the balance point and the amount of heat that you need is small, the amount of supplemental heat that you need is small. So, and again, if possible to just leave the system in, that's great, but think about controls or other options that you can add to try to make the system perform as smoothly as possible. Yeah, all of these systems, there is complexity inherent in this, and we as an industry, as we try to roll these heat pumps into buildings that weren't designed for them, or develop the new systems for new construction where we layer two together, they're all going to have a lot of complexity involved and a lot of potential risk for downtime. So it's, I argue it's absolutely essential to consider having backup in every system as just a fundamental component of design, and never try to do without it, so that the homeowners get the best possible outcome. And then, yeah, sometimes it's just so bloody cold here that your design expectations can be exceeded. You may go below -30 when an air source heat pump turns off, but you may also see heat loads higher than you expected on any system. And the heat pumps, by their nature, they move heat very efficiently, but they move, for their size and their cost, they move relatively small amounts of it. So it's not always practical to think that you're going to cover an entire heat load with just a heat pump.
We had a question, Tom, from Phil. Would you recommend using the balance point temperature as the point to switch over to the backup system, or further to the right on the chart?
So, and the balance point will be somewhat different for every system too. So there are online calculators for helping you work out where you think the balance point is going to be for a system. Practically speaking, you probably won't really know until your system is operated for a while, and you can see where it starts to happen. But if you take wherever the balance point is, then and you think you want to use it as a switching point, I would only do that if I would do that depending on the backup. If, say, for example, you've got an air-to-water heat pump and your backup is a modulating electric boiler, the modulating electric boiler will never do a better job than the heat pump. So it makes sense to continue running the heat pump for as long as you possibly can, because it'll never be, the electric boiler will never be more than 100% efficient. The heat pump will probably never be less. So run the heat pump all season long and use the electric to back it up, and don't worry about switching over from one to the other. Let them work it out in real time based on the water coming out of the tank. If the heat pump's in air conditioning mode for defrost, and the water starts cooling down in the tank, well, that's when the electric boiler steps in to back it up. But if you've got a gas product, maybe it's better to make a positive switch from one system to the other, and actually just shut down your heat pump like they're talking about doing in Montreal. In that case, I would recommend our recommendation on that would be to the right of the balance point. Don't do it right at the balance point, because you would start to see cycling. If you don't want to do it to the left of the balance point, I mean, depending on how you orient these charts, left to right, we should probably put the chart back up just for reference. The way that this one's doing it, the further left you go to the on this chart, the more supplemental heat you need. Well, if you picked, say, negative or 20 degrees Fahrenheit, so it's like -8, -6, something like that. Anyway, If you pick that temperature, then you've got a really small amount of blue there where you would see a lot of cycling on a gas boiler, even a modulating one that with good turn down. It's probably going to cycle on and off a bunch. So that wouldn't be very effective. In this case, then you'd want to pick to the left, to the right of it. So, 35 degrees Fahrenheit, 40 degrees Celsius, somewhere in that range. So you ran the heat pump for the whole shoulder season when the gas boiler might have been cycling a lot because the loads weren't as substantial. And the heat pump took over and ran it and everything was fine. And then when you make the positive switch over, you don't have any cycling issues. The boiler starts running. Like the first time it turns on in that season, you probably have a substantial enough load to keep the thing running all the time. And then you get really good long cycle efficiencies, good gas efficiency on the boiler. So if you're picking based on the location of the balance point, I would always pick to the right in this framing here to avoid the cycling problem. But if you have a backup where you're not worried about cycling, it's an electrical thing that can modulate to precisely what the delta between what the heat pump's doing and what the system needs is, then run both. Don't make any switch over from the heat pump to the backup system at all. Let them go at the same time all year. So yeah, like I said, happy to stick around and talk about technical nerdy stuff if anyone wants.
Yeah, is there any other questions? I know in a previous presentation there was a lot of people asking, wouldn't mind your thoughts on the differences of sizing when you're trying to put in a heat pump with a furnace, and understanding I guess what it takes to size it so you have the proper size for the heat pump.
Yeah, so they do have. There's all the heat pumps will have charts of performance. The air source heat pumps based on air temperature and desired out the temperature and what your speed your VFD is running at and all that stuff. The truth is, more often than not, the heat pumps are not capable of being so big that you have overcapacity. So you can, to some extent, you can put in the biggest one you can manage. If the capital expenditure of the project is too big to put in a 5-ton, so they want to put in a 3-ton, and then that'll move your balance point further to the right because the heat pump's performance is lower. But if that's what they can afford and that's what you want to put on, or that's what the coil that fits on the furnace, you don't want to replace the furnace, so you size it around what you can get away with, then do that. But as a general concept, it's very unlikely that you'll have a lot of excess capacity. And even if you put in, say, a 5-ton heat pump, and you could have gotten away with a 4-ton in terms of the design day load or where the balance point is and what you'd be happy with, then the 5-ton just modulates down and runs at a higher efficiency when it's covering the load than it would have if you put in a 4-ton. So it's kind of a situation of you probably can't put in too big of one. But there may be reasons that make you want to put in a smaller one. You may not have space for a 5-ton. You may have your cost may not stretch to it. Your existing infrastructure may not allow it. But if you can get away with it, then why not? Heat pump in a greenhouse, I see.
Yeah.
There's not really any reason you wouldn't want to do it. The only concern would be they extract roughly as much heat from the environment as you're getting into your house. So if your heat pump is delivering at any given day, say 20,000 BTUs of heat, that means 20,000 BTUs of heat's getting pulled from the greenhouse. So you will cool down the greenhouse. Depending on how big and how much exposure for sun it has and whatever, you may not have a problem with that. It may cool it down, but still be quite warm enough to keep the plants happy and healthy and not have any issue. But you just have to be mindful of the fact that it is going to be an air conditioner in that case. It's going to be as though you switch the evaporator condenser of an air conditioner and just put one of them inside the greenhouse. So you'll be trading heat between the two of them. It's also something to keep in mind of if the greenhouse were to get really cold, like if it did manage to cool it down, then you would at some point run out of thermal energy and the heat pump wouldn't be able to provide heating for the home anymore. You'd have to switch it off. But you could probably, like if you were going to, it being in your own system, you'd be monitoring it presumably. If you were checking and your greenhouse wasn't getting that cold and you were fine with it, then you keep going. But if you notice it got down to 10 degrees C in there or something and you want it to warm up again, switch to backup. And just turn off the heat pump for anything below that outdoor temperature, say, or solar condition, because the greenhouse isn't going to always be as warm depending on what's happening with the weather. But you would learn what are the limits where this can make sense for me. I wouldn't necessarily expect your average homeowner to learn that. They'd probably want a safer switching point. Just pick a specific temperature and tell them to always switch that, or set it up in their controls that way or something. But in theory, there's nothing to stop you. I mean, the greenhouse, you just need the air movement and the thermal energy. So there'd be no like it's a reasonably clean environment. It's not like you have a lot of contaminants in there as a general rule that would, like, even if you have fertilizer, that shouldn't be an option. These heat pumps are installed outside around fertilizer all the time. So there's nothing about the environment that wouldn't make that suitable. It's just make sure it doesn't cool it down too much, or you're going to kind of defeat the point of having a greenhouse. In a way, a greenhouse is a good battery for this, because it does, of course, collect all that solar power. You're making it, you could potentially, especially if you have enough and it's not going to cool down, it could be a great way to collect warm air for the heat pump to run very efficiently throughout the year. But even in that case, again, still want something as a backup just in case it starts getting too cold in there, and you can switch it off. Using a mini split heat pump all inside a basement to cool server room be a good option. Yeah, no, so it is, yeah, if you're just using mini split and cooling mode to cool down a server room and reject heat to a basement, you certainly could. As long as you're prepared for the fact that you're going to have heat in that basement all the time. Like that will be to cool a server room, you'd be talking like a year-round application then. So in the middle of summer, it's still cooling the server room, but it's rejecting the heat into the basement where you no longer want it. If you could set it up somehow that it was diverted in the summer months to outside or something like that, that would probably be preferable. Yeah, I mean, we do see mini splits used to cool server rooms often, but usually they put the other head outside and just deal with they have a backup option for cooling the server room should the weather get so cold it doesn't want to function anymore, or something like that. But yeah, rejecting it into a basement would be an interesting one. If you have a big enough space that you're not worried about the server room creating too much heat to overheat it much, then there's no reason not to. The refrigerant it's not like having the refrigerant loop contained entirely in the house changes much, because refrigerant's in the house anyway. Just the nature of the fact that you have to run it through the wall. So yeah, as long as you're not going to overheat the basement, then it's absolutely something you could do. But if you are, then your air conditioning system for the home is going to have to turn on just to take the heat from then the basement to outside. And then there'll be a bit of a trade-off. You'll be dealing with boosted heating efficiency in the winter months, where you're taking the server heat and making use of it somewhere, but a increased air conditioning load in the summer months.
And just had a question. You guys are involved in the air to water side of things. Is that gaining in popularity now? I know where is that business heading?
It is. Yeah. That was the issue. You'd have to have some other thing going. You could almost have the mini splits to reject heat to outside, and then put like a window shaker air conditioner in for the backup option in the really cold weather. But anyway, yes, no. So they are increasing in popularity for sure. The air to water heat pumps, by definition, of course, they work on hydronic systems, which are statistically far more uncommon than air to air systems in Canada. I mean, most heating in most homes is furnaces. It's in the 90s% of homes that are air to air or rather furnace and an AC unit outside. That's the most common. So air-to-air heat pumps replacing those has been the highest volume in the industry, where hydronic systems with boilers are less common. Air-to-water systems are finding their way into boiler systems increasingly rapidly, and the industry, the hydronic industry, is getting a better understanding of them all the time and how to apply them, how to make sure they've installed them and designed them correctly so they don't have any issues. So it's coming. The big drawback for the air-to-water heat pumps has been that the government, at this point in time, has constantly left the air-to-water systems out of the rebate programs. So there was no air-to-water Greener Homes grant, while there was a substantial one for air-to-air heat pumps. So that's obviously going to be a roadblock for any sale of any heat pump. You know, they are more expensive than some other options because they're inherently somewhat complex. And if you don't have any rebate and the air-to-air product does, then it's going to be a pretty attractive product to go with the air-to-air one. So anyway, so that has definitely caused it to capture the imagination a lot more slowly than on the air-to-air side. If the government, I've seen like internally circulated documents from them that they are thinking, hey, why don't we, like, we want heat pumps to go in, we want to get to net zero. Shouldn't we be including rebates for air-to-water heat pumps as well, and water-to-water and water-to-air and all of them? Because we want as many heat pumps as we can possibly get put in as many homes as we can possibly put them in. So whenever the next generation one comes along, I hope it does include air-to-water, and then that should certainly drive more activity. But even without it, yeah, they're growing in popularity. We're seeing it a lot more commonly now.
Good. I don't know if you saw Frank's question there. Anyone experimented with using refrigeration lines in the ground instead of water lines?
The times I've seen it, they're not in the ground, they're in a conduit. So and still buried, you want them to be below frost line. So similar to water lines, you still want them low, but you don't run them through, you don't even think about running them through soil. You run them through insulated lines through a conduit of some kind, like even if it's just a 4-inch PVC pipe or something, and you run the line set through there. And then you're not worried about the environmental exposure or the thermal loss as it transmits back and forth. And if you do that, that can work quite well. But into a greenhouse, I'm not sure. I'm not sure if anyone's done that.
Okay. Any other questions from people? And also a common thing we heard, and I'll let you plug a little bit of Rheem here in case you can, is a lot of people looking for other technical training outside on heat pumps and so on. Does Train offer anything that people could go check out?
Rheem does.
Sorry, my apologies. Rheem, I don't know why that came up, but yes.
You said training, and then
that was it. So
in your brain,
yeah.
We have we have a technical training team. We can do training on all of our heat pump products, which are many. We have air-to-air, air-to-water, heat pump water heaters, side discharge, top discharge. Yeah, lots of different product, and we do have a technical training team that can support training on that. Both on the equipment, as a manufacturer of equipment, we primarily focus our training on that. But we do have sales training, and we have applications support options. Increasingly common requests to help people lay out how I'm supposed to design the system so that it doesn't blow up in my face. In order to be able to move the equipment, we're going to have to be able to tell you how to have that thing not blow up in your face. So we're getting more involved in the application side of things as well.
Okay, great. All right. Any other questions from people right now? Yeah, the greenhouse examples sounds interesting to me. So
I like the comment though that you want to have the ability to use fresh air. It's an option that makes a lot of sense. So for example, with with a heat pump water heater, you can have it pull heat from inside air from inside and put the in the summer and put the heat into the water, and then duct out the air to outside. And then when you get to the yeah, in the summer you're getting free air conditioning, and then in the winter you turn a damper, and then it starts pulling the air from outside, or at least cooler weather where you might be not necessarily the dead of winter, but the cooler weather. So it's nice to have that sort of option. So if you had the heat pump next to a greenhouse, and then you could pull the air from the greenhouse in the winter, or in the when you're doing heating mode, you want to take the air from the greenhouse because you've collected solar energy. And then as soon as you switch to air conditioning mode, you don't want to be doing that anymore because you don't need the greenhouse to be involved. You want to just run air conditioning using ambient air like normal. Yes, it is. So if you live in a place where the power generation is not clean, then environmentally speaking, the heat pump option starts to make a little less sense. If your electricity is, you're going to consume a certain amount of electricity or a certain amount of gas, and the electricity is generated by burning gas at 50% efficiency, then the heat pump performance has to grossly outperform the gas furnace. Like, it has to be so much more efficient that even though you created the electricity at 50% efficiency, burning gas in your house is still going to be worse because you're going to use a sum total more energy. But if you're in a place where you do a lot of hydro generation, for example, and the electricity is generated in a sustainable, clean way, then basically any improvement in performance on the heat pump over a gas appliance makes it an easy choice. Your environmental impact is better using the heat pump. So parts of the Midwest and Alberta, there's a lot of gas generation. It's a bit harder from an environmental perspective today to defend the electric heat pump option. But the power generation in Ontario and Quebec is relatively clean, so it's much, much easier. So that's true. The thing that should be kept in mind, however, is life of the system and what are the plans for power generation in the area. If the government, for example, says they're going to be having nuclear power by 2030, then you can probably expect that for a lot of the life of that piece of equipment, you're going to be using very clean electricity. So even if you aren't right away, well into the service life of the appliance, you'll be running on clean electricity and doing better than if you were to keep burning gas. So it should be factored in just what's the timing. And vice versa, I suppose, if the government was saying we're shutting down all of our clean power generation, we're going to burn gas because, screw you, environment, then maybe you put in the gas appliance right away so you don't participate in that not so bright option. But yeah, it's basically true that you'll if you have unclean power, the heat pump may not be an environmental net benefit today, depending on the performance, depending on how much better that heat pump's going to be able to do in that system.
Okay. All right. Any other questions? Okay. I don't know if there's more, but yeah, definitely check out Rheem with their training for anything else that they have, and if there's nothing else, then I just wanted to thank Tom for joining us today. That was good because we had a little discussion beforehand because I've been told by many people in parts of Alberta you need backup, but there isn't. So this is actually interesting to hear that, and I think there's a lot of good reasons to have that. You absolutely need backup now after listening. So thanks, Tom. So if anyone wants to, there is that commercial session running, but we're about 10 minutes away from starting our next one. That's a good friend of ours and Tom's, Michael Ridler is going to be presenting next on geothermal solutions, residential geothermal solutions. And Lucas from Train is going to be talking about decarbonization and high efficiency of heating systems for commercial systems. So please join in those rooms, and I think that would be it. So thanks again, Tom. I really appreciate you coming on today.
Yep, no problem. Happy to.
All right, I'll stop it there and hope to see everyone in the next session.